Remember that state variables are packed in Solidity. For example, if we had a state variable UN256 followed by state variable 2UN32, the last two UN32 will be packed into a single slot. However, this is not the case for memory. In EVM memory, data is stored in chunks of 32 bytes. So, for example, here we have UN256X. This will be stored in a single EVM memory slot. The next UN32Y will also occupy 32 bytes, and the last UN32 will also occupy 32 bytes. Let's see an example. Here I created a function called test_read, and inside the function I've initialized a struct called point in memory. This point has the values 1 for x, 2 for y, and 3 for z. Now this point will be loaded starting at memory location 0x80. This is where initially the free memory pointer will point to. From here, 1 will be stored at 0x80, and then in the next 32 bytes, 2 will be stored, and in the next 32 bytes, 3 will be stored. To show you this, I'm gonna write some assembly code, say assembly. We'll assign the value of point.x to this variable x, point.y to this variable y, and point.z to this variable z. So I'll type assign to the variable x, load the 32 bytes that is stored inside 0x80, mload 0x80. And again, this value 0x80 is initially where the free memory pointer points to. It stores the value 0x80, and this means that we can start writing into memory starting at memory location 0x80. The value y will be stored 32 bytes after memory location 0x80. So y will be stored at mload. One way to think about this is saying add to 0x80 32 bytes. This will be 0x20. What we're doing here is adding 32 bytes. 0x20 is 32 in hexadecimal, so add 32 to 0x80. To make this part of the code use less gas, and to also make it harder to understand, we can just hardcode the value of adding 0x20 to the value 0x80. So when we add 0x20 to 0x80, we get, if we add 16 to this value 0x80, we get a 0x90. And if we add another 16, then we need to increment this 9 to the next value, and the next value in hexadecimal will be A. Remember that the value x is a UN256, so it will take up 32 bytes. However, the value y is UN32, so it doesn't need 32 bytes. However, when we're dealing with memory, data will be stored in chunks of 32 bytes. So the last value z will be stored in 32 bytes after 0x80. This will be mload. Again, we can say add to the previous memory slot 0x80, 32. In hexadecimal, this will be 0x20. Again, we can save gas, simplify this equation by saying 0x80, we want to add 32, so let's do the math. If we add 16, this will become a B, and if we add another 16, this will become a C, C0. Okay, so this is an example of how data is stored in memory for structs. Next, let me give you an example of how to write into a struct in memory. I created a function called test_write. Inside here, we'll initialize the point struct into memory, and then store some data, and then at the end, we'll return some data. First, we'll initialize a struct of point into memory. This struct will be stored starting at memory location 0x80. This is initially where the free memory starts. And from 0x80, it will occupy 3 times 32 bytes, or 96 bytes. And I'll also show you that when we initialize a struct in memory, the free memory pointer will be updated. Okay, so I'll first start by writing assembly. Recall that the struct point has 3 fields, x, y, and z. Let's start by storing some number into point.x. mstore at this point struct is initialized starting at memory location 0x80. So I'll start here by typing 0x80. And let's store the value 11. In other words, what we're doing here is storing 11 for point.x. Okay, let's do the same for the values y and z. The value y will be stored at 32 bytes after 0x80. So we'll need to increment this number by 32. Again, to increment it by 16, we increase it by 1, so this will be a 9. If we want to increase it by 32, we'll need to increase the 8 by 2, and this will become A0. And for the value y, let's store the value 22. And then for the last value z, z will start 32 bytes after this 0x80. So this will be, we need to skip 2 values. So this will be B and then C. And the value, let's store 33. And to show you that we actually store the value 11 for point.x, 22 for point.y, and 33 for point.z, what I'm going to do here is assign to this value x is equal to p.x. And I'll do the same for the value y is equal to p.y, and z is equal to p.z. And finally, to show you that the free memory pointer is updated when we initialize a struct, to this free memory pointer, we'll say free mem pointer. The free memory pointer is always stored at 0x40. So here I'll type mload 0x40. Initially, this free memory pointer is 0x80. And what you're going to see when we execute this function is that this free memory pointer no longer points to 0x80. Okay, let's try executing the functions. I'll hit Ctrl S to compile the contract. The contract compiles. Next, we'll deploy the contract. And then we'll first call the function test read. Call the function test read, and we get the values 1, 2, and 3. Next, let's try testing the function test write. Call the function, and for the values, we get 11, 22, and 33. And for the free memory pointer, it points to 0xe0. If we add 32 to this value 0xc0, we get the value 0xe0. In other words, the free memory pointer now points to 32 bytes after 0xc0.